Okay, so welcome everyone. Welcome to my page. Okay, so yeah, so today we'll still continue on where we ended yesterday. So the topic is, for those who have not watched the first one, so we are dealing with complex numbers. Okay, so a complex number, like the way we defined it yesterday, is a number which has a real part, and an imaginary part. Okay, so we have the real part, and we saw how we represent a complex number in polar form. Okay, so this is a magnitude r, it's a vector with a magnitude r and a theta, and this axis is our real, and this one is our imaginary. Okay, so this is just a recap. Okay, so you have your imaginary part. This is the one which has a j. This is the axis which represent the imaginary part, and then the a is the real part which comes this side. So it's jb, then a. This is how you represent complex number on the polar coordinate. So today we'll take it a little bit further. So today we'll see how you multiply. You have two polar, so you have two complex numbers, and then you have to do what with these two complex numbers? You have to get the multiplication, or how do you multiply two complex numbers in polar form? Okay, so let's start with problem 12. So problem 12, we have a, where you have 8 at an angle 25 degrees. You multiply it by 4 at an angle 60 degrees. Okay, so we know 4 is r, for those who don't know. In polar form, a complex number is represented in this form. So this is the magnitude, and this is the angle. So r, we know r is square of the real part plus square of the imaginary part. Like this is how you get r. Okay, that was the topic for yesterday. So today, how do you multiply two complex numbers in polar form? So if you're told to multiply this, so you multiply r, the number here, like I have shown, is r. This is the magnitude, so you multiply the magnitude. So you say 8 by 4. Okay, these are magnitudes. Then you add the angles, so you have 25 plus 60 degrees. Okay, so 8 by 4, what is 8 by 4? This is 32. So meaning here we get 32 at an angle, so 60 by 25, which is 85. So this is 85 degrees Celsius. This is how you multiply. So you multiply the magnitudes and then add the angles. So B, you have 3 at an angle 16 degrees multiplied by 5 at an angle negative 44 multiplied by 2 at an angle 80 degrees. Okay, so same applies. You multiply the r. So r here is this one, r here is 5, r here is 2. So you have 3 by this is 5, 3 by 5 by 2. Then the angles, you have 16 plus negative 44 plus, okay, plus 80 degrees. So these are degrees. So this one is in the bracket, okay, like this. So you have 3 by 5, which is what? 15. 15 by 2, which is 30. Okay, then you have 16 minus 44, which is negative 28, plus 80, you get 52 degrees. Okay, so this is how you multiply complex numbers in polar form. Okay, so this is pretty straightforward. You just multiply the magnitudes and add the angles. Okay, so let's go to problem 11 now. Okay, so problem 11, we have been given, so problem 11a, this is problem 11 here. So problem 11, we are converting from polar to what? So to A plus B, so in this conjugate form, so we are converting from polar to conjugate. So polar, you have 5, okay? So if we were to draw this on a Cartesian plane, so we have this angle is 30, then this magnitude is 5, so we have, this is the imaginary part, imaginary real. So we are supposed to find this and this. Okay, so SOHCAHTOA, we revised SOHCAHTOA yesterday. SOHCAHTOA, okay, this is A. Okay, SOHCAHTOA. So if you see this triangle here, this triangle I've made here with a right angle here, this is what? 30. This is the opposite of this angle 30, and this is the adjacent. Okay, so we are supposed to find this side and this side. Okay, so our A is the side here. This is our A, and this is our B, because it's a distance from here in the imaginary axis, because we are taught to express it in this form. So this is the real part, which is this side, and the imaginary part is this. So without wasting time here, we know sine, so sine 30, if you say sine 30, opposite is B, over hypotenuse is 5. Okay, so over 1, you can cross multiply, so B equals to 5 sine 30, which is, so 5 sine 30 degrees, which is 2.5. Then for A we use cosine because adjacent, so cosine, cos 30, so this cosine adjacent is A, so A over hypotenuse is 5, which is R. Okay, so A equals to 5 cos 30 degrees, so A equals to, so 5 cos 30 degrees equals to, so 4.330. So now we write 5 at an angle 30 is same as A 4.30 plus J, B is 2.5. Okay, so meaning you express this in this form. Okay, so it's very easy. It's very easy. So if you're given, let's say 5, this is very easy. You are taught to express it in terms of A plus B. So we know A is what? In the x-axis. So A is same as in the x-axis. So x-axis we use cosine. So you just say directly say A equals to 5 cos 30. B we know is a y-axis. Y-axis is sine. So 5 sine 30. For those who don't want these soccer at all, you can just know that A is along the x-axis. So x-axis is a cosine function. And B is y-axis. Y-axis is sine function. Okay? So you write A is what? 4.33. B is 2.5. Then we have to write now A plus JB. Okay, so A is 4.330 plus B is 2.5. Okay, just like that, simple. Let's go to B. B is 7 negative 145. Okay, so B is 7 at angle negative 145. Okay, so without wasting time, directly we know A is equals to what? 7. A is along the x-axis, so it's cos negative 145. B is along the y-axis, so it's a sine function. 7 sine negative 145. Okay, so 7 cos negative 145. This is negative 5.734. Okay, so rounding off to 3 decimal places. Okay, then this one 7 sine negative 145 equal to negative 4.015. Okay, so meaning this in terms of A plus JB is A is what? Negative 4.015. There is a minus here, minus J. B is what? Oh, I started with B, so we write this. Okay, so A is negative 5.734. Okay, minus B is this one. Okay, 4.015. Okay, so this is in polar form, in a conjugate form. So we are changing from polar to conjugate. So you have to know how to convert from this back to this. We showed that yesterday. So for those who are a little bit lost, please refer to my yesterday's video. Okay, so that's about this. Now let's come to this other part. The last part of this video, where you solve equations. So these are, you solve the equations. The question is solve the equations. Solve the equations. So how do you solve something like this? Okay, so we've seen how to multiply in polar. So now we come to multiplying in conjugate form, because these are in conjugate form. So let's start with 1. So we have 2 plus j, okay, 3 minus 2j equal to a plus jb. Okay, so we have to find, here we are supposed to calculate for a and b. Here we are solving for x and y. Here we are solving for a and b. Here we are solving for x and y. Alright, so here let's solve for a and b. So first of all, you multiply here. So you have 2 multiplies with this. Okay, then we have j, there is a plus here. So plus, I'm just doing fraction decomposition, multiplied by this one, 3 minus equal to a plus jb. Okay, so now here we do simple multiplication. 2 multiplied by 3, which is 6, minus 2 by 2, 4. Okay, plus, there is a plus here, j multiplied by 3, 3j. Okay, minus, then there is j multiplied by j. So here we have a j multiplied by j. Okay, plus, make positive by negative is negative. Okay, j multiplied by j is j. Then we have a 2. equal to A plus JB. Okay, so we can easily solve this. 6, so negative 4j plus 3j, this is just a j, same as 1j, now we just write j. Okay, then minus j multiplied by j, j squared. Okay, then 2, so here there is a multiplication equals to A plus JB. Okay, so 6 minus j, so negative j is negative 1, j squared is negative 1. We talked about this identity yesterday. Okay, A plus JB. Okay, I'm just trying to solve all the steps here. Minus j, so negative 1 by 2, negative 2, negative 2 plus multiplied by negative here to be plus 2. Okay, equal to A plus JB. All right. So okay, so 6 plus 2, which is 7, this one and this one, minus j equals to A plus B plus JB. So now here we group real terms, imaginary terms. So we have 7 and A. These are real terms. So meaning 7 equals to A. Okay, we've solved for A. Then imaginary part, we have negative j equals to JB. Okay, so we know this coefficient of this is 1. So for completeness sake, so that you don't get lost, you say negative 1j. Okay, yeah, so now you cancel the j. So you have negative 1 equals to B. So meaning you've solved A is equals to what? 7. So A is equals to 7 and B equals to negative 1. These are your answers. So when you reach here, the real part equate them, the imaginary part equate them. Okay, so now let's go to number 2. Number 2, you have 2 plus j over 1 minus j equal to j. Okay, then you have x plus jy. Okay, so this is same as over 1. You can cross multiply. Directly you have 2 plus j is multiplied by 1. Then you have 1 minus j multiplied by this. So this multiplies with this j, x plus y, j plus y. Okay, so here we have a 2 plus a j equal to, so you have 1 multiplied by this which is here. So you have 1 multiplied by j x plus jy. Then you have a negative j, you're multiplying. Okay, negative j multiplied by j x plus j y. Right, so you have a 2 plus a j equal to, so 1 by j is just j. We have x plus jy. So negative, so here we have a negative j multiplied by j to be j squared. Okay, j by j, j squared, x plus jy. Okay, so we continue multiplying further. 2 plus j equal to j multiplied by x, jx, plus j multiplied by j to be j squared y. Okay, minus j squared is negative 1. Okay, then you have x plus jy. Okay, great. So you have 2 plus j equal to jx. So okay, so here let me just raise this one. J squared is negative 1, so this sign becomes negative, because negative by positive it will be negative. Okay, so it will be just negative y. Negative by negative to be positive, so you have x plus jy. Okay, so let's continue solving. So we have 2 plus j ix minus y plus this is just x plus jy. Okay, so now let's put right terms together and real terms together and imaginary terms together. So you have 2 plus j equals to the imaginary part, this with the j, we have j, there is x plus y, this one, this term and this term. Okay, then we have plus, then we have plus, we have x here, x minus this y. Okay, so now we have real term, so you have x minus y equal to 2, and the other equation you have the imaginary part, you have a j, or let's say 1j equals to j x plus y. Okay, so these with the j's you equate them with this one, and then these without a j, the real part. Okay, so we have, so you can cancel the j, so you have x minus y equals to 2, then this one is x plus y equal to 1. So you can solve this simultaneous equation. So here I think we can just use elimination, minus. Okay, x minus x, 0. Okay, x minus this, x minus x, 0. Then negative y minus y, it will be negative 2y. 2 minus 1 to be 1. Okay, so this is negative 2, negative 2. Y equals to negative half. Okay, and then so for x we can use either this equation or this one. So let's use the first one, x minus y equals to 2. So x minus, where there is y we replace with half. Okay, equals to 2. So we have x, this is plus half, equals to 2. Okay, so this goes this side, so x equals to 2 minus half. So x equals to, should be 3 over 2. 2 minus half. Okay, 3 over 2. So 3 over 2. So x, we've calculated x equals to 3 over 2 and y equal to negative half. So you can put these values there, but you see that the answers are correct. Okay, so let's try to solve number 3 now. So number 3 we are solving for a and b. So number 3, same procedure, 2 minus j3 equal to root of a plus jb. Okay, so here we need to get rid of the square root. How do you get rid of the square root? If you have a square root and you want to get rid of this, you square, because we know a square root is same as 1 power 2 half. So if you square, is 1 over 2 multiplied by 2. This and this will cancel, just have 1. Okay, so for us to get rid of this, we square both sides. Okay, hope you guys understand. So for us to get rid of the square root, because we can't solve with a square root, we need to get rid of it. So you say 2 minus j3, so root a plus jb. We square it. Even here we square. So we are not squaring only one side. When you square both sides. So this and this will cancel. So we have 2 minus j3 squared equals to a plus jb. Okay, so now we can solve it. It's become simple. So this is same as 2 minus j3, 2 minus j3 equal to a plus jb. Okay, so now we can do distribution. 2 multiplied by 2 minus j3 This 2 multiplied by everything here minus this j3 multiplied by everything here, so you have 2 minus j3 equal to a plus jb. Okay, so 2 by 2 you have the 4 minus 2 by 3 6. Okay, minus, so negative 3j multiplied by 2 you have negative 6j. Okay, this is negative 3j multiplied by 2. Okay, then negative by negative you have a positive, this negative by this negative you have a positive, then j by j you have j squared, 3 by 3 you have 9. Okay, equal to a plus jb. Okay, so you have 4 here, we can just simplify here. Negative 6j, negative 6j, this is negative 12j. Okay, then plus j squared is what? Negative 1 multiplied by this 9 here. Okay, equal to a plus jb. Okay, so you have a 4 minus j12, so negative by positive negative. Okay, so this is just nice, minus 9 equal to a plus jb. Okay, great. So now here you can combine these are numbers. 4 minus 9 is negative 5. Okay, equals to a plus jb. Alright, so now here you combine real terms, so we have this real term and this one, so a equal to negative 5, then these with j's you combine them. Okay, so we have negative j12 equal to jb, so a j and a j cancels out, so you have negative 12 equal to b. So these are your answers. You can prove by putting these values in the equation, so you definitely get these answers. Okay, so this is how you solve. Oh, not even done yet, sorry. I thought I was done. Okay, so let's solve the last part. So we have so question 4, we have x minus j2y, okay, minus y minus jx equal to 2, okay, 2 plus j. Okay, great. So here this is pretty easy, so you have x minus j2y, so here you just distribute the negative multiplied by y, it will be y, negative by negative positive j x, okay, equal to 2 plus j. Then you group these with the real part, this without a j, so you have x minus y as a real part, then these with j's, so you say plus j, start with this one which is a positive x, then minus 2y. Okay, this is negative 2, negative j to y, so this is okay, great, 2 plus j. So from here now you just equate the real part, this and this, the imaginary part, this and this. So we know x minus y equal to, the real part is 2, then you have j x minus 2y equal to, this is 1j, okay, 1j, just for completeness sake, so that where is the 1 coming from? We know 1 multiplied by j is still j, so the j can cancel out, so you have x minus y equal to 2, then you have x minus 2y, okay, x minus 2y equal to 1. So here we can use the elimination method. So elimination method, we can subtract. X minus x is 0, so negative x minus negative 2y, so negative y minus negative 2y, you would have y. 2 minus 1, you have 1, okay, so we've gotten y. Then now we use the first equation, x minus y equals to 2. We substitute y, so x minus 1 equals to 2. Right terms, x equals to 2 plus 1. Okay, so x equal to 3. So just like that, y equals to 1 and x equals to 3. These are your answers. Okay, so we end here for today. Thank you for following. Invite more friends. Yeah, continue liking my page and continue subscribing. So have a blessed evening. Thank you.